This is r.d.sharma solution, class 12, chapter 19. Exercises 19.21. Indefinite integrals we are talking about. Now here we have under root x square plus 6x plus 10 in the denominator. Please recall that this kind of questions we have solved in the same way except the under root in the previous exercises. Possibility of x represented in the form of differentiation of x square plus 6x plus 10 is one of the possibility. That is, we'll write x as a into d by dx differentiation of x square plus 6x plus 10. So x square plus 6x plus 10 along with a constant b. So this will give us 2x plus 6, which is the differentiation of x square plus 6x plus 10. Now let's multiply this 2ax plus 6a plus b. And this is equivalent to x. Let's equate now these similar terms. So 2ax will be equal to x, and 6a plus b will be equal to, there is no term left, there is no term in the left as 0. So a will be 1 by 2, and when you put this 6 into 1 by 2 plus b equals to 0, this is 3, b gives negative 3. So we have got the value of a and b now. And please remember this equation because this is the numerator we have represented. Denominator remains the same. And we are separating this numerator into two terms. A, which is half into 2x plus 6. So I am writing half here. 2x plus 6 goes to the numerator. In the denominator, you already have this under root x square plus 6x plus 10. So let's write this x square plus 6x plus 10. And b now. So what is b? It's 3, negative 3. And there is nothing here, so it will be simply dx divided by dx also here, dx by under root x square plus cx plus 10. So we have these two terms now. We'll call them as I1 and this as I2. So half and 3 we are going to deal later. So we'll start with this I1, which is x square plus 6x plus 10. And we'll just differentiate it. We've already differentiated it, by the way. It was 2x plus 6. dx goes here. 2x plus 6 dx. dt will be equal to 2x plus 6 dx. So this will be dt. Denominator will be, already we have taken under root t. Now this under root t in the denominator will come numerous times. So let me do it so that we directly use the result in the later part. So this is t equals half in the denominator. Under root t is simply t raised half. So when it goes up, it will be t raised minus half. So when we integrate it, it will be t raised minus half plus 1 by minus half plus 1. X to the power n plus 1 by n plus 1. That's what I am following. So t raised half, denominator also half. So 2 goes up, under root t it will be. T raised half will be under root t. So twice of under root t is the final integration of 1 by under root t. That is 1 by under root x. It was 2 under root x, same way. Half was already there in front, so we cancel these two. Plus constant of integration, let us call it as c1. This under root t, what is t? X square plus 6x plus 10. So x square plus 6x plus 10, I am writing it here. Plus constant of integration c1. First integration result is here. Let's go to I2 now. What is I2 here? We'll deal with this negative 3 later. But can we make this x square plus 6x plus 10 as perfect square? Yes, we can. X square plus 6x plus 10, and this coefficient, this 6 by 2, we divide it by 2 and we square it. It will be 9. So whatever is the coefficient of x, we divide it by 2, square it, add it and subtract it. So a square plus b square plus 2ab x square plus 3 square plus 6x will give you x plus 3 whole square. This is 10 and this is 9. This will give you plus 1. You can write it as 1 square also. So the denominator which we have taken, negative 3, I am not writing right now. I will add it just in a while. So what we got in the under root in the denominator is x plus 3 whole square plus 1 square. So this is simply dx divided by under root x square plus a squared. So x is x plus 3, a is 1 here. So we know the direct integration of this. What is this? Log. Whatever x is there, first write that. And always remember, modulus will always be used inside the log. So modulus x plus 3, which is x actually, plus under root x square plus a square. So x plus 3 whole square plus 1 square, which we got from where? From x square plus 6x plus 10. So even if you write x square plus 6x plus 10, it is same. Now negative 3 was there. plus constant of integration. Let us call it as C2. Now finally we have to do this I1 plus I2. I have already added the coefficients of this integration in front, which we added half and negative 3. Now I1 was under root x square plus 6x plus 10. C1 and C2 will combine, and this C1 and C2 we will call it as a constant of integration, which is capital C. So negative 3 is here, log modulus x plus 3 plus this is plus under root x square plus 6x plus 10, because it was eventually x square plus 6x plus 10 only, if you remember. We just because 3 square and negative 3 square we have added for our comfort, and this is constant of integration. And this modulus also. Now how to do this is in front of you. This is the whole procedure you need to follow, because there are certain points where I need to discuss. That's why I write so many things, which is not you are supposed to write, because you have practiced and you just write these things. Now 2x plus 1x square plus 2x minus 1 under root. Now you will tempted to do the same thing which we have done, and you have to do that way only. But just for the change, there can be another way also. That is, differentiation of x square plus 2x minus 1 is 2x plus 2. So 2x is already there in the numerator. So we just have to add and subtract these two. Okay. So this 2x plus 2, just keep it like that. X square plus 2x minus 1. So we are differentiating x square plus 2x minus 1, we will get 2x plus 2. For that, what is remaining? Because we have added 2 and negative 2 by ourselves. What is remaining here? It's just 1. Negative 1 to be more precise. So we have this x square plus 2x minus 1. This is integration, this is dx, this is integration. Now the same thing we have to follow, which we have done just now. Alright. See, previous question we have done almost the same thing. A into differentiation of the denominator plus some b. And same thing can be done by this way also. Whichever way you feel comfortable, it's up to you. So I'm doing this I1 now, x square plus 2x minus 1. If we differentiate it, dt by dx, you will get this 2x plus 2. Alright. Now dx goes here, so 2x plus 2 into dx is dt. So this I1 will be like this. I1 will be dt divided by under root t. And if you remember, we have already explained in the previous question that the direct integration result you can write, it will be twice of under root t. And you can add a constant of integration, call it as C1. So 2 under root x square plus 2x minus 1. This is the first thing. First I1. Coming to I2 now. So this I2 will be, we have to make the first this x square plus 2x minus 1 as perfect square. So what is the coefficient of x, which is 2? Divided by 2, it will be 1. So you'll get a 1 and square it, add it and subtract it. So 1 square add, 1 square subtract. So a square plus b square plus 2ab is x plus 1 whole square. So you have x plus 1 whole square, negative 1 will be negative 2. You have to make it as a perfect square, so just take under root 2 whole square. Now this I2 has to be written like this. It will be integration of dx divided by under root, which we just got, x plus 1 whole square, and minus root 2 whole square. Now this also integration has a direct result. Integration of dx by under root x square minus a square. This is the result of which we have to use. We already know the result of dx by under root x square minus a square integration. So direct result I am writing log this modulus x plus 1, which is x here in the formula, which is x plus 1 in our question, plus under root. Now x plus 1 whole square minus under 2 whole square has come from where? It has come from x square plus 2x minus 1, original equation. So rather than writing x plus 1 whole square minus root 2 whole square, you can directly write x square plus 2x minus 1. And I'm adding a constant here, which is C2. And C1 plus C2 becomes C. This is the I2. We have to add just I1 here. So I'm writing I here only. Actually, I was I1 plus I2. So this I1 we have already computed, which is 2 under root x square plus 2x minus 1. So just add these two, or you have to subtract. Yes, it's a negative. So subtract, and this from here to here is a final result. C1 plus C2, we have already called it as a capital C. Alright. So this is the way you are going to follow, and these steps are very important. The previous question, also the way we have carried out the question, you can also go about it. 4 plus 5x minus x square. Now here the problem is we have a quadratic equation with a negative x square. That will create something. So what is the differentiation of 5x minus x square? 4 plus 5x minus x square? It's simply 5 minus 2x. So 5 minus 2x, how to get this x plus 1 in terms of 5 minus 2x? It will be real tricky because you have to multiply this x with a negative and divide it by 2 and multiply it by 2 like this. So rather than doing this, just say x plus 1 equals to the differentiation of 4x plus 4 plus 5x minus x square plus b. So x plus 1 will be equal to, just differentiate it. It will be 4 will be 0, 5x will be 5, and negative 2x it will be. 5 minus 2x already showed you, this was the differentiation. So 5 minus 2x plus b. So this will be 5a minus 2ax plus b. So you get this this minus 2ax I'm bringing in the front, and 5 plus b is here just to equate with these similar terms on the left. So x can be equated with negative 2ax. So negative 2ax will be equal to x, and then 1 will be equated with 5a plus b. So 5a plus b will be equal to 1. From here you get a equals to negative half, and negative half has to be put in this equation. 5 into negative half plus b equals to 1, and this will be 1 plus 5 by 2, that will give you 7 by 2. So we have got a as negative half, b as 7 by 2. So this integration, basically we have just done x plus 1. Alright, this equation is only for x plus 1. The denominator remains the same, and I am separating these two terms a and b. So a is negative half, so I am bringing it in front of integration. 5 minus 2x is here, and denominator remains the same. So it will be under root 4 plus 5x minus x square. And what is the second term, which is 7 by 2? It's plus, so don't worry about that. Plus 7 by 2, integration of, and there will be only dx here because there is no other term here. 7 by 2 is already being brought up in front of the integration. So 5 minus 2x dx in the numerator of the first term, dx in the numerator of the second term. And denominator remains the same for both of these, 4 plus 5x minus x square under root. Okay, this is called as I1, this is called as I2 now. So start up with this I1, and just you have to put 4 plus 5x minus x square equals to t. And since the differentiation has already been done, which I showed you, 5 minus 2x, dt by dx will be equal to 5 minus 2x, dt will be equal to 5 minus 2x into dx. Alright, so I1 is this, 5 minus 2x dx, so this will be dt, and this is under root t, and this integration will be twice of under root t plus constant of integration. And since this t was 4 plus 5x minus x square, so we can just replace it by this one to complete this I1, call it as c1, the constant. Okay, now let's do the I2 now. Integration 7 by 2 will deal later, negative half, oh you just multiply this negative half with 2 because 2 is going to get cancelled. So minus half you multiply, 2 gets cancelled, negative 1 will remain, negative under root 4 plus 5x minus x square. In the second term it will be 7 by 2. Now 4 plus 5x minus x square has to be made as a perfect square. That is the only thing which is special in this question. Otherwise all other things remains the same, because you cannot have a negative x square in order to make it as a perfect square. So 4 plus 5x minus x square, first we have to take a negative out and then make this x square as positive. So before doing this, because this 5 will remain there, so I am first taking negative outside. It will be x square and this negative 5x and negative 4. Alright, now negative 5 divided by 2 square, which is what we have been doing, has to be added and subtracted. Now a square plus b square 2ab, x square plus 5 by 2 whole square minus 5x is simply x minus 5 by 2 whole square. You already know that. X minus 5 by 2 whole square, this is the first term. Please remember negative is already outside. We have this remaining term is 5 by 2 whole square, which is 25 by 4. This is negative 4 also. Just take out negative, and 25 by 4 plus 4 is 16 plus 25 by 4, which is 41 by 4. And we have to make it as a perfect square. So how to write it as a perfect square? This is under root 41 by 2 whole square. And I told you negative is already there outside. So this will form as dx divided by, this is under root 41 by 2 whole square. But negative was already there outside. So the second term will come in front. The term will get swapped. So under root 41 by 2 whole square minus x minus 5 by 2 whole square. Now you know already the integration of this one. This is simply integration of dx by under root x square, a square minus x square. It's a square minus x square. So it will be 7 by 2 sin inverse x minus 5 by 2 divided by under root 41 by 2. Let's resolve this. 2x minus 5 by 2 it is, and under root 41 by 2. 2 gets cancelled. So I'm just writing this because I'm going to add directly it with this term which we got here, negative under root 4 plus 5x minus x square plus c1, because eventually we have to add i1 and i2 because I is equal to i1 plus i2. So I'm writing i1 first. It will be negative under root 4 plus 5x minus x square, and this c1 and c2 combined, call it as c. And what is this i2 term, which is 7 by 2 sin inverse 2x minus 5 divided by under root 41, and this will be constant of integration, calling it as capital C. This is your final result. Alright, so this is your result I was talking about, and this is the way you are going to go about it. This question is special because we have a negative x square under root, and that needs some effort, and that needs explanation also. This question will take in the later part. Thank you.